Hey guys, how's everything going? This is Jaser. This is another episode of my YouTube series React source code walkthrough. In the previous episode, I've covered how suspense works in React 18, the concurrent mode, and in that episode, I've mentioned that under the hood of suspense, there is actually this off-screen component which does the trick. So in this episode, I'm going to take a deeper look at how off-screen component is working. And as the React 18 official blog says, the React team is going to expose this off-screen component to the usage side, and we can look forward to that coming. But until then, we can only understand how it works by looking at the source code. Let's begin. So I've put up a demo of how it works. Let's just open the demo. There's a problem here is that because this component is not exposed yet, we cannot use it directly. So I built this experimental build of React so that we can use this component. So you can see that the source code is like this. We use the off-screen component, and for the app, we have this state toggle it or not, and we use this off-screen component. The off-screen component has a property called mode. We can define the mode as hidden or visible, and inside of it, use the children, we could wrap any component we want. Here is some lifecycle logs here for this component itself. We use layout effect and use effect. And while we look at the log here. There are a bunch of logs. We toggle it. There are some other logs. So the first, you can see that update off-screen component, render root concurrent, update off-screen component, render 0, hide, and render again, and the count becomes 1, and it has become hide or unhide children true. It looks as jargon, but don't worry, we'll cover it. So let's go back to our code here. So when the first time it is rendered, it should be render app, and then off-screen and component, because the initial state is hidden. Hidden, so it is hidden, and component, and render component. If we just filter the render, it will be easier to understand, I guess. So render root sync, because it is initial mount, it should be on sync mode, render app, and then it render root concurrent, and then render component 0, count is 0, and render effect, and render concurrent, render 1. So we can see that things, because it's still hidden, right? But the component is rendered, but it's not visible. We can see some interesting things. The first one is, when the component is invisible, it is still rendered. Yes, it's rendered. Passive effects are run, because you can see that effect in component it's run, but layout effects are not run. The layout effect is this one. It sounds reasonable because it's still invisible. If we toggle it, we can see the component itself. It's like a render and number there. Render root concurrent is called twice. You can see that this twice here. When component is visible after clicking the button, layout effects are run. Layout effect is run. So by this observation, we could see that the off-screen defer the rendering of the invisible contents and hide them with the CSS. I left out a step here. Let's inspect it. We can see that the number actually is there. It's just display none with this important override. So it means that the component is rendered, but it's controlled by CSS. It's invisible to us. But why render root concurrent mode? Concurrent is called twice. There's something deeper inside. Let's just I can cover it later, but let's just do a spoiler. Is that we can say that though it's there but it's invisible, how can React do that, right? You're rendered, but it's invisible, and why do you do that? This is and you might think that we could implement this simply by ourselves, right? Use the CSS as the props. We could do some off-screen command by ourselves, but actually we can't because this off-screen component is so special that React will render it in a lower priority, which means that the component inside of it, it's rendered, but it's rendered after everything else is rendered. That's why the render is called twice. In the first pass, this component is not rendered actually. It will delay, and when the other things are rendered and then committed, and then it will render again. And this time it's just focusing on the invisible content, and then they will be added to the DOM and controlled by CSS. It's still a little ambiguous, right? No worries, let's continue. So the first thing is about the data types of off-screen component. There's nothing special actually. It's just we've already briefly touched about it in the last episode. It's just some data flags like identifiers to mark this component as off-screen component. Nothing special. One thing is that it has a state called hidden or visible or unstable defer without hiding. I don't know what it is for now. Let's skip it. And another one is off-screen state. I'm not sure about the details yet because it's related to some cache pool. I don't know what that is for now. But remember that when the state is not empty, it means there are some work to be done. It means it's invisible. Yeah, this is important. This is an example from the last episode when the suspense rendered a off-screen component. You can see that the mount suspense primary children function. There's a mount work in progress off-screen fiber. This is how we use the off-screen component, and the mode is visible. When we are rendering the children, not the fallback. So this is the off-screen component. How we do the reconciliation. This is the function. It's pretty big chunk of code. But let's first look at the outline. This should be pretty straightforward. So if the next property is next state, it should be hidden. It will check if it is a legacy mode, and then it will check if the render lane contains off-screen lane, and then it will render it. So here is the trick. In the first pass, because when we are rendering something, as we covered in the previous video, React will pick up the highest, the lanes with the highest priority, right? Usually the sync lane, and then the continuous interaction, continuous lane, and then transition lane, and then retry lane, and then some lanes. And the off-screen lane is actually has the least priority. It's even lower than the idle lane. Idle means that, okay, if you have some time, you do it. And this off-screen lane is even lower than that. It's, it's just I think it's just could be called idle lane 1 and idle lane 2, right? It's just it doesn't make any difference, I guess. Anyway, it's off-screen lane. It's very low priority. So usually, if there's some other work to do, this won't be true because the off-screen lane is not added. It means that this is the first pass when we are rendering an invisible component with this off-screen component. So it will start preparation to defer the rendering of this off-screen component in this branch. And then if the off-screen is in the render lanes, it means that, okay, we're now rendering the offline component, so we are safely to render. So this is for the hidden. Now, if the next mode is visible, it's just as straightforward because it's visible. We're just rendering a visible tree. So this is the trick. Now, notice this is how React differs the off-screen rendering. Yeah, this how off-screen rendering is scheduled. We've already covered. And this spawn cache pool, it's about cache. I don't know it for now. Let's skip it. What it says here. Okay, here is, we're hidden and we're not rendering at off screen. We'll bail out and resume the tree later. As we said, we're not rendering the off screen, so we will just skip. And here you can do that. You can see that he does something of merge proof base lane and render lanes. Why this is something tricky. We will cover it soon. Suppose the case. This is very important. I will explain it in a lower speed. So, if you're rendering at a sync lane, like a user interaction triggers some state update, and the target fiber is under off-screen component, what will happen? And it will render, and off-screen is invisible, so we will bail out, right, at the off-screen component. So the component that received the user interaction cannot be updated because we already bailed out in the first pass. And then when we continue the invisible rendering at off-screen lane, we need to include the sync lane, right? Why? Because if we don't include it, the update scheduled with the sync lane cannot be updated because we're rendering different lane. That means that because when we are rendering the invisible off-screen component, we actually skip some rendering of current render lane, even though the current lane may be sync lane or any lane above the off-screen lane, right? We will just stop there and say, okay, later we will render off the screen lane. But the work actually is not done yet, so that's why we need to track of the previous base lane and merge them, and so that the work could be rendered. I created another video to explain this. Is that okay? Suppose we have a component like this. It has an internal state. Could be could be changed by the user click, and then in the app, we have an off-screen component wrapping this component, right? Okay, so in this click event, we both set the state and also the parent hidden state. So the off-screen component will become invisible, and also the state of this inner component will be updated. So if you open the demo, and the console, you could see that some logs there. So the first is that says subtree render lane is set to this. This is sync lane, yeah, because user interaction all sync lane, and then it will push render lanes 1 to off-screen. Because off-screen the invisible kicks in, it will bail out. This is why we push the 1. 1 is the sync lane, and then the second render it was set to off-screen. Renders again on off-screen lanes, and then sub-render tree lane is set to this because this is it combines the first sync lane and this off-screen lane. So you can see that this is off-screen lane, this is sync lane. And enough priority, this is because, as we mentioned before, every update on the state hook, it has this priority lanes attached. So if lanes are not, they will not there, they will not render it. So here, because sync lane is included, it will say, okay, it has enough priority. So this is why. This is how the lanes are merged, stashed and merged. Okay, and and the next line is you can see that this is the off-screen lane. It set the child lanes to work in progress lanes. What does this mean? Is that it will update the lanes of the off-screen component. Remember when we were rendering in the previous, I think there are some, wait a minute, traversal. In this traversal, no, not traversal, is bailout. We've basically roughly covered the things called lanes and child lanes. Lanes means if there's some work to do about the fiber itself, the child length means that there are some lengths of work to work on for all the descendant fiber. So when we set lengths, it basically means that, okay, for this fiber, we have some work to do. And oh yeah, this link is, I'll fix this. There should be a link clickable. Remember also we covered before, when the user clicks the buttons, update the state of a component, actually there's a method called mock update length from fiber to root, which will update the child lengths for all the ancestor lengths until the root. This is a way to ensure that update is scheduled. But here, there's no such method. Yeah, but it must be handled somewhere, but it's not here. Let's just keep that in mind. Okay, the next one is create some Offscreen state, and Offscreen state, and set it to memoir state. Remember, I've said that the existence of Offscreen state is to indicate that this fiber, this Offscreen component is invisible or not. And then it's returned now. Reconcile, when we return now, it means that there's nothing work below. So you don't need to go down to the children. And now it's time to complete. And then in complete, we could find this switch branch for Offscreen component. It's pretty long, but we can see the basic idea is that it will get if the next one is hidden or not, and then next one is hidden. If next one is not hidden, and this is the initial mount or something, and yeah, and here it includes. It's pretty complex, but it checks if the state changes. Where is the check here? Yeah, here. If it is visibility changes, it will set the flag for the Offscreen, which is the visibility. Yeah, and also there's a method called bubble properties. Bubble properties here, it says, yeah, if it is not hidden, it will bubble the property. And yeah. The puzzle is solved here, as mentioned, how the parents, the ancestor nodes are marked with the length, child length. It actually is done in the bubble properties here. You can see that when the Offscreen fiber is passed in, if it is debate out or not. If not, it means that it will debate out. Where debate out is the okay, see, completed order and child equals complete child. I didn't understand what is checking here. So this is work in progress, Offscreen fiber. The ordinate is the previous, right? Ordinate child, if it is equals, it means it is bailed out. Interesting. But anyway, let's continue. And hopefully we could get the answer right away. Here, you can see that. So from the name of this variable, it says if did it bail out or not. If not bail out, it will bubble the earliest expression. This is some legacy command, and it's very hard to understand. But basically, let's continue here, I guess. Yeah. No, the last one actually. God. Here, actually. Okay, sorry. We could just ignore the part here. I'm not sure what is going on, but the last line here, completed work child length will be the new child length. This is interesting. The child length, new child length, where's the new child length? New child length is no length, and then the new child length will be merge child length, child length. So you can see that this completed work, what you do is actually collect the child length of this child. Well, child will be child sibling. This while is for all the children, because the next level children collect their child length and set it to itself. And this, because this complete work, it will be done. Complete work will be done. Recursively. So this will be actually in the commit phase. In the complete phase, it will be go straight up to the root. So it actually does the from the perspective of setting the length, it will does something similar to the function we mentioned, mark update from fiber to root. So this is how the lengths are marked to the work is update of the off-screen component is scheduled. Yeah. So why we're doing it complete? Because this action is this update. Wait a minute. When we are user triggering some actions, we know that fiber should be updated. We can actively update the ancestor nodes, but for the update here, it could be it is not from the user interaction, right? You see that when we are rendering off screen, we don't know yet. We don't know whether they should be marked as the length should be marked updated or not. We just render it and check the mode. So this is some lane changes during the render. That's why we do it in a complete work, because there's always a complete phase. We will go to the root anyway to mark it as complete. So why don't we use that phase? All right, it's already there. So yeah, that's for better performance, I guess. Also, remember that ensure root is scheduled is always called after some update is committed. And then in the first pass, because in the first pass we bail out, we don't render anything inside of the off screen, so it will be committed. And then this function will be called again, and then it will check. It will found that off screen lane is set, and it will start rendering the offset off screen. But if there are other important lanes like transition lanes, other retry lanes, the off screen lane will be the least priority to render. Interesting. So how off-screen rendering is done? This is the second render. Now we can render the component inside of the off-screen. There's nothing so special, right? It just push some lengths, blah, blah, blah. So the consider, different from the bailout is that there's no return now. So it will go down straight down to the children, which is the component, and then it's just a normal reconciliation. One thing you might be wondering is that how it is rendered but hidden from DOM. We've already covered in the screenshot that is controlled by CSS, but let's jump into some details. Before we jump in, let's recall how it handles intrinsic DOM elements. I think in the very beginning of this YouTube series, we've seen how it is done. It's actually in the complete phase, and because it's host component, and we will create the DOM node and append all the children. So in the complete phase, and that's why the tree structure was well preserved. Append all children to this instance, and this will be called, complete work will be called recursively to update to the root, and so all the nodes will be created and attached nicely. But something interesting here is that because as we said, in initial pass, if it is invisible for off-screen component, nothing is rendered, right? The content is empty. So for its parent or any ancestor host node, these appended children actually will append nothing inside of the off-screen because it's not there. It's not created yet. And the second pass, it will start rendering. It will create a node. It will create a node. But here's the problem. It will go to the complete work. This update phase. This is actually the initial phase. And next one is because there's already a state node there. It will update them. It will check these children if there's change or not. But But since we don't change anything in the fiber, we just set the length work. So actually it will receive nothing. So for the update, it's not added. So summary, in the initial pass, in the first pass, nothing is rendered. So the host above the host node, which is DOM node above this off screen, it will have empty things. It will know nothing up inside. And the next pass, even though the stuff inside is rendered, still the host component doesn't know anything. So it will not add them. So it's like a detached node. So when is that added? You might be wondering, right? So when it's rendered, we will cover this soon. No worries. Don't worry about that. Okay, this is a branch that when the off-screen component becomes visible from hidden, there's nothing fancy here. Just as we, same as before, we don't return now here, so you would just go to the children. Okay, this is the true core of off-screen component. This is in the commit phase. This is very interesting. Let's be more careful. There is something called commit reconciliation effect. We will cover this soon. And here is the visibility flag, as we mentioned that, right? When we are committing the off-screen component, the visibility flag will be set if the visibility changes, like when it's changing from invisible to visible, or from visible to invisible. So this means that we need to do something. So here's the interesting part. Hide or unhide all children off-screen boundary is hidden. There's this method handles the hiding logic, and here is that if now is now not hidden and this one was hidden, is hidden and was hidden. So was hidden was true. No, was hidden was false. So wait a minute. Oh, what is that? Is hidden. What is hidden? Oh yeah, this one is is hidden is new state. So now is hidden and previously was not hidden. Previously is visible and now is hidden. You can see what it is. What it do? It will disappear layout effect to begin. Yeah. So the layout effect is handled here. It doesn't look like the appear layout effect. Disappear layout effect. Okay, let's see what the disappear layout effect is. Okay. Subtree. This is the. Oh, wait a minute. Off-screen child. This is component. If something disappear layout effect. Hook layout. Fiber return. Hook list unmount. Oh yeah. This is the cleanup actually. This is the cleanup of layout effect. But when is the layout effect is run, I think it should be in this method. Yeah, is it? Okay, this is interesting. Is there something called a disappear appear layout effect? Reappear layout effect, I guess. When it is called, it's you can see that it's it's hidden. If it is hidden, still hidden, don't reappear. This reappear complete. Let's say reappear. It looks like this one. commit layout effect begin. It's interesting. Okay, as I remember that when we are using the layout effect, actually it's when the DOM mutated, and right after it will go through all the changed nodes. It will find the layout effects by the flag called layout hook. Layout, I think it's called layout or something. Wait a minute, layout mask. Not layout mask. It's the layout. Where is the layout? I think it's layout hook. Layout effect. Ooh, I forgot here. Anyway, let's first come back to our post here. Anyway, sorry about that. I'm a bit lost, but let's continue our journey based on the blog I wrote. This is something of me learning, so I'm not the authority to make some right and also like efficient explanation of concept. Cool. Okay, so let's go back here. In the commit phase, for the off-screen component, it will check if the visibility changes, and it will hide or unhide all children accordingly, and also clean up the layout. And in the hide or unhide all children, this is some if. There's a lot of ifs, but the thing is that it will goes down to its child and it will keep trying until find the first host component. Yeah, because this child might not be a intrinsic DOM elements, but something other abstract or context something. It will find all the children and set them, and it will hide the instance here, hide the text instance, or hide instance, unhide, hide, something like this. So in the hide instance, and you can see that it will just use the CSS, set the style. Cool. So if we're debugging here, we set the debugging here, you can see that the DOM is actually added and then hide it. And because it's in the commit phase, the DOM is flushed synchronously. So there's no chance that you can see that flickering. There's no rendering chance before that. This is some, I would say some hacky. I would thought that React does something more clever, but obviously it's not. So in the end, there's a question left, right? When is the DOM connected? Remember, when we're rendering the invisible DOM in the a complete phase, it's not actually attached to the DOM tree. It's actually, as I mentioned, there is a method called commit reconciliation effects here. So it's actually done there. In that function, it will check the flags of placement, and it will commit the placement. This is why. This is how the DOM inside of the off-screen component is added. I was a bit confused about why it's named reconciliation. Now I understand that it's kind of like because this is like a real reconciliation in the real world. There's some discrepancies between the rendering, right? Before concurrent mode, everything is rendered just asynchronously. There's no such thing as off-screen different priority stuff. But now we're introducing the off-screen, so it means that part of the DOM tree is rendered differently. And our logic before still works. It means that, as I said, in a complete phase, it will add nothing and update nothing in the second pass. So from the React runtime's perspective, and everything is right, but actually there are something not right because we are deliberately introduce this behavior, and that's why the whole thing needs reconciliation. There are some discrepancy here. Yeah, this is it. And then it will insert the DOM nodes, and then it will be hide it. Let's do some summary. Sorry, I might not explain it pretty well, but I hope I can help help you understanding better of the Offscreen component. If I have better understanding of it in the future, I definitely would make a better explanation. Sorry about the inefficiency here. Anyway, let's summarize. The first thing is that Offscreen component has a state called visible or hidden. There are some others, but we'll skip. If it is hidden, as I said, it will defers the reconciliation of Offscreen lane by bed out in the first pass. It will check the window links and schedule the work of itself. And if it is visible, it just normally reconcile. Yeah, and just to go to this child. And in the complete work, a complete phase, visibility flag is set if the visibility changes, and also if it is visible, the DOM is already inserted here. Yeah, and but in commit phase, the hidden DOM is inserted here because it's for the hidden, it's not done in the complete phase, and also React will hides and unhides the DOM nodes if visibility flag exists in the commit phase. So the last paragraph, what it is, yeah. Why it's so complex? We can do it by ourselves. I've already answered the question at the beginning of this video, is that we can achieve that by ourselves, but we cannot defer the rendering of the off-screen component. We cannot improve the performance without some built-in mechanism of concurrent mode. Cool, this has been longer than I thought. Sorry, hope it helps. See you next time. Bye-bye.